Okay, we're going to look at some set notation with probabilities now. Guys, one thing to keep in mind, the idea of probability, we're gonna always look at the um, objects or the number of objects that I'm interested in. And that's going to be divided by like the number of total objects. So objects that we're interested in over that. So if you can keep this idea, that's pretty important. That'll help you with this. So for example, guys, we all know if we are flipping a coin, I ask you what's the chance that you get a hedge, you guys are going to tell me 1/2 because. And if you go back to this idea, I'm interested in the heads, which there's only one head, and then there's 2 total, so that's why it's 1/2. And so it's a really simple idea. If we get into some more complicated probability, if you can keep that simple idea, I think it helps you with this, okay? So we're going to do this with our sets. So I've got my sets right here. I'm looking at my sample space here of those 10 objects. And let's just say I ask you what is the probability of getting an object from set A, and we're going to use this notation. It'll be P parentheses A. So that's just shorthand for probability of selecting something from set A. Okay, so that's what this reads right here. And so I just look at how many objects I'm interested in. So set A, there are 5 of them, and then the total, which the total is going to be my sample space. That is 10. So 5/10, that would be my answer. If you we can represent probabilities either with a fraction, or we could reduce this to 1/2, or we could put it as like 0.5 as a decimal, or we could put it as a percentage, which should be 50%. I don't care which way you guys represent them. It does not matter to me unless a problem is telling you like, hey, you need it as a percentage. But this is just a reduced fraction. This would just be dividing 1/2, which give me 0.5, and then 50% would be timesing this 0.5 by 100. Okay, so whichever way you want to represent that. Okay, so if I look at this next one, let's say I was looking for the probability of getting an item from set B. That would be this notation. I'd look at the items that I'm interested in. That would be from set B. So there's 2 of them, and they're 10 total again. Again, you could represent this as 1/5, or you could represent it as 0.2 or 20%. Just pick one of the 3. Okay, let's say we looked at this with actual intersections and unions. So let's say I asked the probability of A intersection B. So remember, this is the I'm interested in those that are the overlap of those. So if I look at that, there's only one that has an overlap here. So that would be my desired outcome or my interested outcome. And I'm still out of 10 at that point in time. So I can just leave that as 1/10. If I look at the probability of, let's say, A union C, now I'm looking at anything that's part of A or C. So that would be 1, 2, 3, 5, 8, and then I've already counted 4 or 2, and so I've got 4 added to it, 6 added to it, and then 10. So there would be 8 objects because I've got these, and then I also have 4, and I also have 6, and I also have 10. These 5 and then these 3 that come from this one. So my desired, it would be 8, and then my total would still be out of 10. And if you want to reduce that, that would be fantastic. This would be 4/10, or 4/5, which would give you about 80%. Okay? So that's how we're looking at finding probabilities that way. The other thing you want to be able to do is be able to be given a situation, like what you guys see right up here. And you guys want to be able to answer questions. A lot of you guys are pretty good at most of these. For example, right here, if I'm rolling a 6-sided die and ask you what's the probability, this is saying what's the probability of rolling a 4. Well, a lot of you guys know the sample space. There's a 1, a 2, a 3, a 4, a 5, and a 6 in my sample space, right? And so I'm interested in a 4, so that would be 1 over however many total there are, which is 6. And so I'd be a 1 in 6 chance of that occurring. So same thing here. This is saying the probability of getting a number less than 4, but not equal to. So less than 4, the ones that I'm interested in is either a 1, a 2, or 3, because those are all less than 4. So there would be 3, and then there are a total of 6 objects here. So 3 out of 6 that would be there. Okay. Let's look at a different one. This is, we're going to flip a coin twice, and we're going to let T be a tails and H be a heads. What is my sample space from flipping 2 coins? So my sample space, I could either get a heads on the first and a heads on the second, right? Or I could get a heads on the first and a tails on the second, all right? Or I could get a tails on the first and then a heads on the second. And then the last option would be you get a tails on both of them. And those would be your 4 options for flipping 2 coins. So once you've got your sample space, this is really nice because there's 4 total, there are 4 total options. Heads, 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 tails, tails, heads, or tails, tails. Then I can start finding my probabilities. So this one's saying, what's the probability of tails of tails? Well, guys, there is one interested one that I'm interested in, or that I want, and there are 4 totals, so that would be 1 out of 4 that would occur. Okay? If I look at this next one, what's the probability of a heads tail? Well, there's only one that's a heads and then a tails. Now, if I don't care, like if I get a heads first and a tails second, then I can have both these, but since I am only interested in the heads and the tails, that would still be 1 out of 4 as well. So, and that's what you'd get for that. All right, so that's your set notation with probability. Again, objects you're interested in divided by the total. Knowing the set notation stuff would be very helpful. So this has been your Math Moment with Money. Adios.